condensation and the precipitation, you call them as what? Hydrological cycle. Correct? Right. You call them as hydrological cycle. So what we have done in the last class, we started discussing about each and every compartment of this cycle. Correct? It means we started with atmospheric moisture or humidity. What is atmospheric moisture? The amount of water vapor present in either in atmosphere or right in a specific air column. You call them as what? Atmospheric moisture. Or sometimes you call them as what? Humidity. Correct? So after understanding the definition of humidity, we talked about how exactly this water vapor is added into the atmosphere, the so-called source. Correct? And we have also seen that how exactly this atmosphere moisture is measured by it. Okay? Though there are different ways of measuring it, but I told you the better way, right? The better way of measuring it is what? Relative humidity. So what is relative humidity? Somewhere we understood. Correct? Right, friends. So we also understood what exactly is condensation. Am I right? So having said that, I also talked about the different forms of condensation. Right? We talked about on-ground condensation. We talked about near-ground condensation. Am I right? Only thing is that today we have to talk about atmospheric condensation. Correct? Right, my friend. So, right. So we'll just say, for example, continue from where exactly we have left. Okay, right, my friend. Now, as I said, we have to talk about this. Right, we completed this on-ground condensation. On-ground condensation, at least we have seen two types of condensation. One is dew and two is frost. When we talk about near-ground condensation, we talked about fog and mist. Correct. So we'll be talking about this atmospheric condensation. So my dear friend, as I said, we'll be talking about this atmospheric condensation. Right, last class itself we have seen this atmospheric condensation is very popularly called as what? Cloud. Am I right? So directly or indirectly, we are going to discuss about cloud, my dear friends. Okay, cloud. Now see, most of us have an idea as though this cloud itself is what? Water vapor. But last class I have clarified, at least I have just told you, this water vapor is a transparent gas. It's transparent. It means you cannot see it. That's what I understand, right? Only if the water vapor becomes water or ice crystal somewhere, right? I understand the transparency slightly gets affected. Water is also transparent, right? But not as transparent as the gas itself. That's what I want to say. So somewhere I want to tell you that cloud is not water vapor. Cloud is the condensed form, right? Cloud is the condensed form. Okay. If you want to say, for example, that's the reason we said, right? What is condensation? Gas either becoming liquid or solid, you call them as what? Condensation. Correct. In that regard, cloud is an aggregate of solids and liquids. If you want to take the definition of cloud, kindly take it, my friend. This is a WMO's definition, World Meteorological Organization's definition. You can take it. Cloud is the aggregate, right? Or I would say, cloud is the visible aggregate. You can write it. It is a visible aggregate of tiny ice crystals. And minute water droplets. Cloud is a visible aggregate of tiny ice crystals and the minute water droplets. So this definition itself will tell you that cloud has both liquids and solids. Right? Either in clouds you will be finding small, right, very tiny ice crystals, solids, or very minute water droplets. Am I right? Liquids. Right? Okay. Now everything is fine. Okay. So what is a cloud? We have an idea. Now, when I talk about the classification or differentiation of cloud, right? Clouds can be classified in different forms. Say, for example, based on different, say, for example, bases. You can classify the cloud based on its shape. You can classify the clouds based on its weather effectivity. You can classify the cloud based on its height. Am I right? Any way you can classify it. So my difference in that regard, If you ask me, okay, how exactly this cloud can be classified? Say, for example, as I told you, right, you can classify them in different, say, for example, right, bases. Say, for example, if you're just classifying the clouds based on its shape, okay, maybe I'll just take it side by side, how exactly these clouds can be classified based on the shape, based on the weather effectivity, and based on the height. So if you're just classifying the cloud based on shape, my dear friend, clouds are of three types. Number one, right, you call them as what? Cumulus clouds. Right? How exactly this cumulus clouds will look like? Say, for example, this cumulus cloud, the most commonest form of cloud, my friend. All right. Whenever I say cloud, right, this is the depiction what I bring, correct? It's known for its globular mass. Right? It is globular in shape, globular mass. All right. Like, say, for example, right, how exactly you'll be having these pieces of cotton, right? You just take the piece of cotton, right, put a dark piece of wool, whatever it is, right? That's how it looks like, my friend. Globular in its mass. Cumulus, the most commonest cloud. The second type of cloud, you call them as what? Stratus cloud. Stratus cloud. So how exactly the stratus cloud will look like, I'll tell you. Stratus cloud is more like a sheet-like cloud, my friend. Right? They are more horizontal in nature. Okay. Or somewhere try to remember it. Okay. Even I'll just go for a different representation. All right. So the stratus cloud is more right sheet-like structure. It's more horizontal in its extent. Okay. It is more like a sheet-like structure. One is vertically globular in its mass. One is more horizontal and it is spreading like a sheet. Stratus cloud. Okay. The third type of cloud, we call them as what? Cirrus cloud. You call them as what? Cirrus cloud. So what is cirrus cloud? Right? A very thin fibrous clouds. Right? Fibrous. Very thin fibrous clouds, you call them as what? Cirrus clouds. So if you want to classify the clouds based on shape, these are the different types of clouds you have, my dear friends. Okay. I'll show you how exactly these clouds will look like. That I'll show you, right? See, forget about the combinational cloud. I'm just bringing the major clouds. When I talk about the major clouds, like somewhere what exactly you're seeing here, right? Everyday sky, you can see this, my friend. Somewhere you'll be finding the globular mass, all right? Right? You'll be finding a globular mass, right? You call them as what? Cumulus clouds. Okay. You call it as a cumulus clouds. Sometimes you'll be finding, say, for example, very thin fibrous structure in the cloud, means almost in the, say, for example, sky, very fibrous structure. See, this is slightly better, I think. I'll just zoom it out. Zoom in, right? Right? Very globular in mass, you call them as what? Cumulus. Right? Spreads like horizontal sheet-like structure, you call them as what? Stratus. Very fibrous, thin, fibrous structure, you call them as what? Cirrus. Right, my dear? So these are the three major types of cloud when it comes for shape-based classification. Okay, right. Right, my dear friends. Okay. Now, assuming that, okay, approximately we know that the types of cloud based on shape. Now comes the question, okay, What are the other classifications, if you ask me? Clouds can also be classified based on its height. Okay. So when I talk about height, what are the clouds which is based on height, if you ask me? Right? Number one, all this cloud which is based, say for example, very close to Earth's surface, or I would say in lower altitude, you call them as what? Low altitudinal cloud. You call them as what? Low altitudinal cloud. So how low it is, if you ask me? So all the cloud which is located at the height of 2.5 kilometers and below, right? You call them as what? Low altitudinal cloud. Clouds which is located, right, between this 2.5 and say for example 6 kilometers, we call them as what? Mid altitudinal cloud. Okay, all the cloud which is located between 2.5 to 6 kilometers of height from where? Surface of the earth. Okay. Now you may ask me, right? Say for example, right, in mountain, what exactly you call them as? Mountain is a different story. So whenever I say this height is generally with respect to, right, mean sea level. Okay, generally. Okay. Then I have something called as high altitudinal cloud. High altitudinal cloud. Okay. So all that cloud which is located beyond the 6 kilometer mark, you call them as what? High altitudinal cloud. See, these height, what I'm just giving you, this is an approximate. So for example, in the image, what we will take, you may see 6.5 or you may see 7 kilometers, right? That should not make a much difference. Correct? And my dear friends, finally, if you ask me, is there any other classification of cloud? Yes. Clouds can also be classified based on weather effectivity, right? Weather effectivity. Right. Based on weather effectivity. Means what exactly is the weather? It is inducing. Correct. In that regard, few clouds you call them as what? Fair weather cloud. What is this fair weather cloud, if you ask me? Fair weather. Ask me what exactly is this fair weather cloud. Cloud will be there, but this cloud will not result in precipitation. That is what you call them as what? Fair weather cloud. Am I right? No precipitation. Correct. Right. Number two, you call them as what? Rain bearing cloud. Rain bearing cloud. So what is this rain bearing cloud, if you ask me? This cloud results in precipitation. Now you may ask me, right, is that, say for example, do you mean to say that all clouds will not result in precipitation? Yes. All cloud will not result in precipitation. Sometimes what happens, you'll be feeling, means you'll be seeing a cloud, but this cloud will be there, but rainfall will not be there. Correct? That's what you call them as what? Fair weather cloud. And whichever cloud brings rain, you call them as what? Rain bearing cloud. And the third cloud we have, right, we call them as what? Bad weather cloud. Bad weather cloud. Now comes the question, right? What do you mean by this bad weather cloud? Right? Intensified rain bearing cloud is called as bad weather cloud. Intensified rain bearing cloud. And my dear friends, this intensified rain bearing cloud, what I call it as bad weather cloud, this bad weather cloud is very popularly called as nimbus clouds. Nimbus clouds. So my dear friends, the entire classification, what is important for us, if you ask me, knowing this nimbus is important. Okay. Then knowing this cumulus, stratus and cirrus is important. That's the reason whenever you just talk about the types of cloud, you will be seeing 4 types of cloud, not 3 types of cloud. Okay. The only thing is that I want to tell you that, say for example, the basis of classification is different. Right, the basis of classification is different. Okay. So few you classify based on shape. Few you classify based on height. Another few you classify based on weather effectivity. Am I right? It's the combination of all these things. Nimbus cloud, I call them as what? Bad weather cloud. Now you have the biggest question, right? What do you mean by bad weather cloud? My friends, you yourself can tell me. I am talking about this bad weather cloud, right? Whenever I say bad weather cloud, what can be that bad weather effectivity? Forget about this bad weather cloud. Okay. Just tell me, what can be that bad weather, my friend? Just maybe you can type the answers in chat box. You can type the answer. Only things that I cannot hear you, right? Even if you're just speaking, I cannot hear you. Okay. My dear friends, just say for example, just give it a try. When I say bad weather, intensive rainfall causing flood. If that is the case, slightly, okay, whatever Pankaj has said, okay, I'll just change it. Whatever he said is perfectly right. Let me call it as what? This is the cloud which results in what? Like cloud burst. Cloud burst. Often you're saying, right? Himachal Pradesh is becoming, say, for example, so many number of landslides. Cloud burst. Am I right? Okay, Sneha has said storms. Okay, I understand, right? Let me put it this way: thunderstorm, right? Thunderstorms, right? Anything else, my friend? Cloud burst. Cloud burst means heavy, very heavy precipitation in very less span of time. You call them as what? Cloud burst, my friend. Anything else? Even lightning you can add, right? Thunder and lightning, what exactly is the difference? Am I right? If this phenomena happens with the sound, you call them as thunder, right? Only the flash of light comes in, you call them as what? Lightning. All right, lightning, right? You call them as what? Lightning, my friend. Anything else, right? What you can add to this bad weather, my friend? See, somewhere you would have seen this, or you would have heard about this hailstorms, right? Hailstorms. Now, what is this hailstorm? See, for example, whenever it is precipitating, am I right? All precipitation you cannot enjoy it, right? See, I'll show you this hailstorm. Sometimes what happens, a large chunk of ice will be falling from the sky. See, my dear friends, don't mistake it for a golf ball. This is not a golf ball. These are the ice crystals, right, which is falling from the sky. Am I right? As, right, big as, right, say for example, possible. Just to tell you that they are highly destructive in nature. Am I right? Even if you ask me that which cloud results in this hailstorm, see, for example, they are very, say, for example, they are life-threatening. They are life-threatening. They can destroy your property, especially the parked vehicles, right? They are very life-threatening for the cattle, say, for example, who are grazing outside, even for us. Even for us. Say, for example, if we do not have a protection as such, right, it can be fatal also. Am I right? This is what you call them as what? Hailstorms, my friend. You call them as a hailstorm. Again, if you ask me, which is that cloud which results in hailstorm, this is nimbus clouds. Okay. So lightning, thunder, hailstorm, cloudburst, induced flash floods, right, my dear friends? Everything is associated with what? This nimbus clouds, my friend. Am I right? That's the reason you call them as what? Nimbus clouds or bad weather cloud. Right? You call them as what? Bad weather cloud. Okay. So nimbus clouds are dark clouds. So nimbus clouds, they are just very dark clouds. Dark clouds. Okay. Why it is dark? Because the cloud is so thick. Am I right? So much of condensed material you have, the sun's rays cannot penetrate. That's the reason it has become so dark. Am I right? Okay. Now, my dear friends, all these clouds, the types of cloud we have taken it. Am I right? Types of clouds. Now, I told you only thing is that now we have to see the combinations. Okay. Different, right? Say, for example, basis we have taken it. Now we have to look for the combination. Okay. Now, my dear friends, all the combination taken together, right? Height-based classification, right? So this image also I'll just paste it somewhere. I told you, right, what is very important for us. So I'll talk about the types of cloud. Right, the four major types of cloud, I should call it as, right. How exactly these clouds looks like, that also I have just given you. But this is four major types of cloud. If you're just going for a simple classification, these are the four different types of cloud. But I told you, right, it means cloud can form a combination. If clouds are forming a combination, then actually there are 10 different types of cloud method. Now comes the question, is it necessary to remember? See, always I would say in geography, if you ask me, is it necessary to remember all? I do not know how you can remember all, but I can feel one thing, it is not possible for you to remember all. Right? Right, my dear friends, whatever be the case, right? If I'm just going for all combinations, right? Shape-based classification, height-based classification, and right, the weather effectivity-based classification, and bringing the, say for example, bringing them together. I have 10 different types of cloud coming into picture. My friends, as I already said, right? See, height-based classification, low altitudinal cloud, mid altitudinal cloud, and high altitudinal cloud, and based on the slightly the values are different. Okay, never mind about it. I have just taken it as what, 2.5 kilometers. So this low altitudinal. So what exactly I'm just drawing here? It's low altitudinal. Then comes mid altitudinal. So what you have is mid altitudinal cloud. Somewhere I have just marked it at 6 kilometers. Okay, height. Now, my dear friends, here only the four major types of cloud we are taking it. If you remember, shape-based classification, we have taken this cumulus. Right, we have just taken this cumulus cloud. Then we have taken this stratus cloud. Then I have just taken this cirrus cloud. Then when I talk about the weather effectivity based classification, we have just taken the fourth type of cloud. This fourth type of cloud, we call them as what? Nimbus cloud. All right, nimbus cloud. Okay. Only these clouds I have just taken, and their combination makes 10 different types of cloud. See, for example, see, independent cumulus, independent stratus, and their combination called as stratocumulus. Right? Cumulus along with the nimbus, cumulonimbus, stratus along with the nimbus, stratonimbus or nimbostratus. Similarly, cirrus and stratus put together, cirrostratus. Cirrus and cumulus put together, you call them as what? Cirrocumulus. Right? Then I have something called as altocumulus and altostratus. Now, how to approximately remember this, I'll tell you, my friend. We have taken this cirrus, right? Cirrus is high altitudinal cloud, and this nimbus is low altitudinal cloud. And you should not ask me, see, cumulonimbus is marked somewhere here. My dear friends, okay, whatever is the height of the cloud, that is not material means, that doesn't matter for us. Where exactly the base of the cloud is located, right? With that, you classify. Okay. With the base of the cloud, right? We are just classifying that where exactly, what exactly is the classification of this cloud. Okay. So what I wanted to tell you, cirrus, as I already said, cirrus is high altitudinal cloud. Nimbus is low altitudinal cloud. As the case, the cirrus and nimbus will not go for any combination. No, cirrus will be there only in high altitude method. So see it. See this cirrus. Now cirrus and stratus forming a combination, cirrostratus. Now cirrus and cumulus forming a combination, cirrocumulus. Over. No more cirrus. 3 types of cloud is over. All right. So if you're there in mid altitude, cirrus is also not there, nimbus is also not there. What you have is only cumulus and stratus. Cumulus has a prefix called as altocumulus. Stratus has a prefix called as altostratus. So mid, you have this word called as alto. So altocumulus and altostratus. Now you come to the lower altitude, right? independent cumulus, independent stratus, their combination. Cumulus becoming intensified as cumulonimbus, stratus becoming intensified as nimbostratus. Over. Correct. 10 different types of cloud, we have an idea. Again, I'm telling you, should I remember all these 10 different types of cloud? Not necessary. Okay. What you want to remember, what you have to remember is only one type of cloud. This cloud is very important. This cloud, you call them as what? Cumulonimbus clouds. This is important for your examination. My dear friend, I repeat again, I told, right, what you have to remember is what? Cumulonimbus cloud. Cumulonimbus cloud. Okay. This is important. Why? Because, say, for example, this cumulonimbus cloud, often it is called as towering cloud. Towering cloud. Okay. Towering cloud, or sometimes you call them as what? Multi-altitudinal cloud. Towering cloud, or you call them as what? Multi-altitudinal cloud. Okay. And say, for example, I could say this cloud is the one wherever, my dear friends, whenever you have the bad weather effectivity, right? Very bad. Right? Flash floods, right? Flash floods, hailstorm, lightning, thunder, anything you take it. That will be the result of this particular cloud. All right. Now comes the question. Okay. How exactly this cumulonimbus cloud is formed? Okay. What is exactly leading to its formation? Is it all of a sudden this cumulonimbus cloud will be formed? No. Right? Any cumulonimbus clouds always starts as a cumulus cloud. And over a period of time, it will transform itself into cumulonimbus cloud. Okay. It's a cumulus cloud. I'm just writing this cumulus cloud. Cumulus cloud will get transformed into cumulonimbus cloud. Okay. As I said, cumulus cloud will get transformed into cumulonimbus cloud. Okay. So it means it becomes so vertical in nature. Now, this is how this cumulus cloud, right, over a period of time becomes cumulonimbus cloud. Right? A globular mass, say for example, it becomes a, I put it this way, right? It becomes, right, a towering cloud. If you ask me what exactly makes this cumulus to become a towering cloud, if you ask me, a strong vertical movement within the cloud. Strong vertical movement within the cloud. We call them as what? Updraft and downdraft. So whenever I say updraft and downdraft, these are vertical movement within the cloud. All right, strong updraft and downdraft. Okay. Now you may ask me, right, what is this updraft and downdraft, right? As I said, vertical movement. See, for example, whenever this condensed particle starts moving vertically within the cloud, this cloud will start growing in its time. Now comes the question. On what occasion, why exactly, say for example, I'll be having updraft and downdraft if you ask me. Updraft. Why exactly these particles should rise? Right, very strong updraft should be it. Right, my dear friends, they will rise, right, whenever there is a very strong rising convection. Not just rising convection, wherever you have a strong rising convection. Right, when you have a strong rising convection, you'll be having this updraft. Okay, right. We'll be having this updraft. Okay, now everything is fine. Cumulus, whenever you experience a strong rising convection, then you will be having updraft. I'll also show you that, right? Diagrammatically, how this cumulonimbus cloud is formed. somewhere, just for your reference. Okay. How this cumulonimbus cloud is being formed, right? What you have is a very strong, right, updraft and a downdraft, my friend. Whoever has drawn this image, okay. Let's thank them. Okay. How exactly this cumulonimbus cloud is formed, right? Somewhere they have explained it. A strong updraft should be there and a strong downdraft should be there. Somewhere, my friend, if you ask me, right, what exactly results in strong updraft, vertical movement of this cloud, right? We call them as what? Strong rising convection. Okay. What is convection? Whenever this air mass starts rising, right? Whenever this air mass starts rising vertically, you call them as what? Rising convection. Now you have to tell me, okay, where generally you experience this rising convection method? Somewhere you can say, for example, put it in the chat box also. Where exactly you will be having this rising convection? Fantastic, right? Pankaj is saying that ITCZ it, right? ITCZ is nothing but what? Equatorial low, correct? Very good. Not only equatorial low, my friend. Wherever you have warm condition, right? Very good, fantastic, right? Wherever you have this warm condition, there all you may experience what? This, right? Cumulonimbus cloud. That's the reason I said. See, for example, whenever you experience this hailstorm, right? Most of the time, hailstorm is the result. A hailstorm will be resulted in a warmer location, not in a colder location. Colder location, you may have snowfall, but not hailstorm. Correct? Right, my dear friends. Okay, good. Your understanding is pretty good. Okay, right. So how this cumulus cloud becomes cumulonimbus cloud, that also we have taken it. And my dear friends, normally, if you're there at the, say for example, apex of this cloud, right, top of this cloud, okay, top of this cloud, normally you'll be finding that this cloud is normally extended towards the eastern side. Okay, this you call them as what? Unbuilt top. Unbuilt top. So everywhere you'll be finding this unbuilt top. See, here also you find this unbuilt top. Correct? You find something called as unbuilt mic. Right. Any cumulonimbus cloud, on reaching this tropopause level, you will be finding a tail-like structure which is normally extended towards the eastern side, my friend. Okay. Now I have another question for you. Can you at least somewhere correlate the earlier topic and tell me why generally there is an eastward extension of this cumulonimbus cloud? Not every time. Whenever it reaches this tropopause level. Whenever it reaches the tropopause level, it goes slightly, it almost extends towards the eastern side. Very good. Very good, Mr. Pankaj, right? Why? Jet stream. Because I understand jet stream flows from what? Jet stream flows from west to east, Mike. So the jet stream flows in west to east fashion. This cloud will also extending towards what? East. Okay. Very good. Fantastic, right? So this is all about cloud, and here I'm telling you all these topics, what I'm just telling you, they are very important. They are very, very important for your preliminary examination, right? Very important in your preliminary examination. Okay, all these things, right? Hydrological stuff. Okay, so what we have done? Atmospheric humidity we have completed, condensation we have completed, and finally, right? We are there in the last cycle. Last compartment of this cycle, you call them as what? Precipitation. The last stages of this hydrological cycle, precipitation. Okay. See, what is precipitation? As the layman, if you want to understand what is a precipitation, I would say example of precipitation: rainfall, snowfall, hailstorm. All these are forms of precipitation. Okay. Forms of precipitation. Now, why this precipitation happens? See, what is precipitation? Anything which falls from the cloud, you call them as what? Precipitation. It should fall. Am I right? And one more thing, without cloud being formed, precipitation is not possible. Condensation is a prerequisite for precipitation. Without condensation, there cannot be precipitation. Am I right? So my dear friends, kindly take this definition. A small definition. What is precipitation? The gravity fall of the condensed material, gravity fall of the condensed material from the base of the cloud. Gravity fall from the condensed, gravity fall of the condensed material from the base of the cloud is called as precipitation. See, my dear friends, you have cloud. Cloud is full of condensed material. Slowly, steadily, if the size of the condensed material is growing, see, for example, ice crystal. These ice crystals will be, say, for example, combining with other ice crystals. Slowly, steadily, if it is growing in its size, okay, growing in its size, at one point of time, right, these ice crystals can fall with the effect of gravity. Am I right? So whenever it is falling with the effect of gravity, right, you call them as what? Precipitation. That's the reason we say, right, gravity fall of the condensed material with the, right, gravity fall of the condensed material from the base of the cloud. Okay. Why exactly it is falling? Because of the gravity, right? When this cloud cannot withhold this, right, large sized crystal, it will fall. Am I right? Okay. So what is this precipitation? We have an idea. Now, my dear friends, if you ask me, okay, what are the different forms of precipitation? Different forms are there. Okay, forms of precipitation. Right, forms of precipitation. The most commonest form of precipitation, if you ask me, my friend, right, I would say the most commonest form is what? Rainfall. Right, rainfall. Right. You know that, say, for example, what is rainfall? Rainfall is nothing but what? Fall of water droplets. Okay. Fall of water droplets, you call them as what? Rainfall. And whenever I say rainfall, I can also include a drizzle, my friend. I can also include drizzle. What is drizzle? Immature rain, I call them as what? Drizzle. Right? Immature rain. So immature rainfall, I call them as what? Drizzle, my friend. Small, small water droplets. All right. Small, small water droplets. Right. You call them as what? Drizzle, my friend. Okay. Right. Similarly, when I talk about, say, for example, snowfall, am I right? When I talk about snowfall, what exactly is snowfall? Snowfall is nothing but what? Ice flakes. Am I right? Ice flakes. Like if I have, say, for example, ice flakes falling, you call them as what? Snowfall. And say, for example, when I talk about snowfall, what is drizzle to rainfall? Something similarly, we also have snowfall, my friend. Number one, I have glaze. Okay. What is glaze? Glaze is partially molten snow. Partially molten snow. On the other hand, I also have something called a sleet, my friend. Sleet is refrozen or refrozen glaze, my friend. Refrozen glaze, right? You call them as what? Sleet. How exactly the sleet will look like, I'll tell you, my friend. Right? Sleet is more like ice crystals, right? They are small, small ice crystals, my friend. They are actually small ice crystals. Okay. Sometimes the sleet is called as mini hails. Small, small ice crystals will be there. But the only difference between hailstorm and sleet is also ice crystal. Hail is also ice crystal. Sleet will be small in its size when I compare, means small size of ice crystal, hail will be large size of ice crystal. And one more difference, my friend, sleet is generally common to colder areas. Hail is common to warmer areas. Am I right? They are small ice crystals, my friend. If you want to write that point, you can write it. I'll also show you. Then the third, what you have is what? Hailstorm. Okay. So talk about hailstorm, it's a large chunk of ice. Large ice crystals. We call them as what? Hailstorm or hail. Okay. I'll just show you, my friend. What is this? Rain, snow, sleet, and hail. Almost all what we have discussed, it is there, right? What is snow, what is sleet? So let's say the basic difference. Okay, no problem, my friend. See, what I want to tell you, say for example, small ice crystals, what it is forming, right? That's what you call them as what? Sleet. Okay. So liquid precipitation that freezes before reaching the ground. Okay. You call them as what? Sleet. Okay, right. Okay. So I have a doubt on jet streams. No problem. This jet stream questions, if you have a doubt, once the class is over, you can ask me. Okay, right. Right, my dear friend. So just showing you the different forms of precipitation. What are the different forms in what the condensed material will be falling from the cloud we have taken it. Approximately, you can imagine also water droplet falling, rainfall. If it is falling as an ice flake, snowfall. Partially molten ice flake, it means one side it will be ice flake, another side it is, say for example, snow will be there, soft snow will be there, you call them as what? Glaze, right? Hardened ice crystals, you call them as what? Sleet. Okay. Hailstorm, very large, say for example, chunk of ice, you call them as what? Hailstorm, my friend. Am I right? So these are some of the forms of precipitation, right? And my dear friends, if you ask me types of precipitation, there are some types of precipitation. Okay, types of precipitation. What is this types of precipitation? See, my dear friends, see for example, whenever, say for example, precipitation is happening, am I right? For precipitation to happen, I already told you, right? Condensation is a prerequisite for precipitation to happen. Condensation is a prerequisite. Okay, without condensation, precipitation will not happen. Without cloud, there is no precipitation. So now comes the question, whenever I say types of precipitation, actually we are saying that how this condensation is facilitated. Okay. Now one thing I understand, my friend, on what occasion condensation is facilitated? How exactly condensation will take place? Very simple. Temperature should get reduced. How temperature will get reduced? Only one way. Increase the height. So whatever mechanism is increasing the height, accordingly we say so. For example, if an air mass rises along the slope of the mountain, here the mountain will be aiding condensation and precipitation. All right. We call that type of precipitation as orographic precipitation. If I have a front, climatic front, which is helping this air mass to rise, we call them as what? Frontal precipitation. If on its own, if it is rising because of a very strong rising convection, then we call them as what? Convectional precipitation. Am I right? So my dear friends, if I just talk about the types of precipitation, there are 3 or 4 types of precipitation. Orographic, frontal, and convectional precipitation. Right, these are the 3 major types of precipitation. You also have cyclonic precipitation and others, right? But I'm not taking into details, right? Only these basic 3 elements I'm just taking it, right? Orographic precipitation, frontal precipitation, right, and convectional precipitation. See, for example, whenever this air mass is rising using the slope of the mountain, am I right? So one side of the mountain you call them as what? Right, windward side, and another side you call them as what? Leeward side, rain shadow regions. As it, say for example, increases its height, it becomes cold and moist, it goes for condensation, it results in precipitation. Am I right? So this type of precipitation we call them as what? Orographic precipitation. So my dear friend, what exactly you're seeing here? You call this as what? Orographic precipitation. Am I right? Then my dear friends, apart from orographic precipitation, what are the other forms of precipitation? Here itself somewhere. Maybe I'll just select the easiest one. See my difference. Say for example, when a mountain, along the mountain, if the air mass is rising and it is going for a precipitation, you call them as what? Orographic precipitation. And if it is using a front, am I right? What exactly you're seeing here, you call them as what? Front, my dear friend, climatic front. We call them as a front. Okay. What is a front? Say for example, when 2 contrasting air mass converge with each other, generally along the mid latitudes, right? Along the mid latitudes, right? You have this front which is created. All right, right? Mid latitudes, along this mid latitudes, my friend. Okay. You have something called as front which is created, right? What is this front? If you ask me, see, one side you will be having cold air mass and one side you will be having warm air mass. This cold and warm air mass will not readily mix with each other. Let's say, for example, other diagrams, what exactly is showing here, right? See very carefully if I'm just seeing this. Okay. Say, for example, one side what you have is cold air mass and another side what you have is what? Warm air mass. This cold air mass and warm air mass will not readily mix with each other, whereas this warm air mass will start rising over this cold air mass. The boundary between this cold and warm air mass is what? Very popularly you call them as what? Front, or you call them as what? Climatic front. Now what exactly you are seeing here is also this climatic front. So generally what happens, my friend, the warm air mass, right, will start rising over this, right, cold air mass. Okay. Cloud will form and it will result in precipitation. Such precipitation we call them as what? Frontal precipitation. We call them as what? Frontal precipitation. You call them as what? Frontal precipitation. Okay, right. And finally, my friend, if I just talk about, say, for example, if you're there in a warmer region, very warm conditions, okay, warm regions, right, what happens? You will be experiencing the rise of air mass on its own. Whenever the air mass is rising, that will go for condensation and precipitation, right? Such type of precipitation, you call them as what? Convectional precipitation. Convectional precipitation. Okay. So these are the three different types of precipitation what we have. Forms of precipitation also we have seen. In what form it is forming. Number two, how exactly this precipitation is facilitated. See, all these three diagrams, one thing is common. What is common? Everywhere this air mass is rising. Correct? It is rising. Number one, using the slope of the mountain, it is rising. Number two, using the climatic front, it is rising. Number three, on its own, it is rising. Correct? Whatever be the case, only if the air mass rises, it will go for condensation. Otherwise, it will not go for condensation. Remember, this is fundamental method because it uses one very important property of this atmosphere called as normal lapse rate. Okay, it uses this normal lapse rate as a phenomenon. What is this normal lapse rate? Everybody knows, right? You increase the height in atmosphere or at least in troposphere, the temperature decreases. For every 1 kilometer you increase the height, how many degrees centigrade will decrease, my friend? Any idea? Talking about this normal lapse rate. If normal lapse rate would have not been there, condensation would have not taken place. Right. Somewhere you studied, right? For every 1 kilometer, you increase the height. What happens to the temperature? By how many degrees the temperature decreases? Any idea? Very good. Fantastic. 6.5 degrees centigrade, or somewhere you can also say for every 165 meters, the temperature decreases by 1 degree centigrade approximately. Right? This is what you call them as what? Normal lapse rate, my friend. Right? Because I know why it is going for a condensation. When air mass rises, the temperature comes down. Gas will become water. Water will become ice crystals, as simple as this. Okay. This, we are completing this hydrological cycle. Okay. All facts about hydrological cycle we are completing. My dear friends, climatology is one chapter which is very important for your prelims as well as mains examination. Okay. So, prelims, if at all, if you're having a question, I put it this way, right, hardly, right, you may not have a question which falls outside this climatology, or I would say every year, climatology question is mandatory. Okay, it comes. So, we have completed the structure and composition of atmosphere. We completed insolation. We completed temperature and its distribution, both vertical and horizontal. We completed all types of pressure systems. We completed all types of winds, right? We have taken the, say for example, the cycle of water in atmosphere called as hydrological cycle. It means we have to talk about climate, world climate. That's all. Okay. But in between, my friend, I have left few topics. What are the few topics I have left in it? When it comes to pressure, I did not talk about the intense low pressure system called as cyclones, right? So cyclone is one topic what I have left. Number two, when it comes to wind, we discussed about planetary winds, We discussed about local winds, we discussed about jet streams, but what we have not discussed is a wind called as regional wind, and this regional wind called as monsoon. Right? These are the two topics what I have not discussed, and these two topics are very, very important. That's the reason I thought I'll discuss at the last. So we'll complete cyclone and monsoon. Then we'll be going to this world climatic classification. Okay, right, my dear friends. Now, proceeding further, after completing this hydrological cycle, right, moving further, right. Now, we are getting into the intense low pressure system called as cyclones. Cyclone is explicitly mentioned in your main syllabus, right? As the case, cyclones are very, very important. So what is a cyclone, if you ask me, my friend? Cyclone is nothing but what? Intense low pressure system. Intense low pressure system. Oh, we are going to discuss about this intensified low pressure system. Okay. What is a low pressure system? I know. See, if you remember pressure system, we talked about cyclone and anticyclone. Anticyclone is intensified high pressure system, but anticyclones we are not interested in. Because mains there is no syllabus and prelims it is not important. Because anticyclone results in a kind of stability. Stable condition means no precipitation, nothing. Cyclone results in instability. Instability is that condition where you will be having what? Say for example, precipitation. Say for example, the wind as such, the high velocity wind, etc. So generally, when I talk about stable condition, we are not very much interested in stable condition. Stable means stable. Am I right? It means no changes as such. So only thing is that we are more interested in understanding the unstable condition. Right? Cyclone induces that unstable condition. Okay. Right, my friend. So cyclones, as I said, it is an intense low pressure system. Now, when I talk about cyclones, my friend, there are two types of cyclones. Am I right? There are two types of cyclones, if you ask me. What are the two types of cyclones? Okay, I'll tell you. Right. Generally, the cyclones are of two types. What are the two types? Two types of cyclones. Generally, say for example, based on the place where exactly it is having its weather effectivity, number one, you call them as what? Tropical cyclones. And number two, you call them as what? Temperate cyclones. Temperate cyclones. Okay. You call them as temperate cyclones. Okay. You call them as tropical and you call them as what? Temperate cyclones. Okay. Now, what we'll do, we'll just have a general differentiation between this tropical cyclones and temperate cyclones. Okay. So one side, let me take this tropical cyclone. See, of course, what is very important for us is this tropical cyclones. Okay. On the other hand, what you have is what? Temperate cyclones. Temperate cyclones. Now comes the question, okay, tropical cyclones and temperate cyclones. Okay, we are just going to discuss the difference between them, right? Basic difference between them. Okay. What is the basic difference between them? I'll tell you. Okay. Number one, when I talk about temperate cyclones, let me introduce the other names of temperate cyclones. What are the other names? How exactly it is called as? Okay. See, this temperate cyclones, my friend, takes different names. For example, temperate cyclone, sometimes it is also called as mid-latitudinal cyclones. It's called as mid-latitudinal cyclones. Sometimes it is called as extratropical cyclones. Sometimes it is called as wave cyclones. Am I right? You call them as what? Mid-latitudinal cyclones. You call them as what? Extratropical cyclones. You call them as wave cyclones. Sometimes you call them as what? Frontal cyclones. Right? You call them as wave cyclones, or you call them as what? Frontal cyclones. Here itself I'll write. Too many lines it is taking. Frontal cyclones. Okay. So this temperate cyclones takes different names, my friend. It takes different names, but the concept is very simple. But the names what I have for temperate cyclones is very, very high. Now, when I talk about, say, for example, tropical versus temperate cyclones, what exactly is the basic difference? I'll tell you, right? And my difference, say, for example, countries like India, what exactly they experience? They experience this tropical cyclones. Okay. So, the basic difference, if I'm just bringing it to my friend. Okay, what are the basic difference? When I talk about tropical cyclones. Okay. Number one, locationally speaking, where exactly I'll be having this tropical cyclones, if you ask me, right? This tropical cyclone happens between 8 degree, right, to 35 degree. Am I right? 8 degree to 35 degree in both the hemisphere. Both the hemisphere. Okay. 8 degree to 35 degree in both the hemisphere. Okay. That's the reason. See, they are confined to the tropical latitudes. That's the reason they are called as tropical cyclones. Temperate cyclones, where exactly temperate cyclones has this effectivity, if you ask me. Okay. They are confined to mid latitude. What is this mid latitude? You know, right, my dear friends? Mid latitude. This is around, somewhere around 60 degree, my friend, right, in both the hemisphere. Correct? In both the hemisphere. Okay. Basic difference. Locationally, right. Temperate cyclones happens in temperate latitude. Tropical cyclones happen in tropical latitudes. Number one. Number two, origin or genesis. Genesis or origin. All right. Formation. Right. Genesis is only in waters. To be very precise, you call them as what? Tropical marginal water body. What is this tropical marginal water body? You will understand later. Don't worry now. Okay. Right. Somewhere you can write it. The genesis is in tropical marginal water body. Okay. Tropical marginal water body. Okay. Only in water, right? It has its origin. Genesis can be both over land and water. Very important. Genesis can be over both land and water, my friend. All right. See, this difference is very, very important. Tropical cyclones can be formed only over water. Having its effectivity is different. Formation is different. When I talk about temperate cyclones, it can have its formation over both land and water, both. All right. Okay. Basic difference, my friend. Number two, few more difference. Temperate cyclone are very high in its intensity. All right. They are high in intensity. Okay. High in intensity. Talk about high in intensity means what? Heavy precipitation and high velocity wind. Am I right? Heavy precipitation. Okay. And high velocity of wind. Right. High velocity of wind, my friend. And high velocity wind. Okay. It is known for intense weather, right? High in intensity, right? Or you call them as what? Intense weather mechanism. Am I right? High in intensity, or I would say, right? Slightly, I'll just change it. Intense weather mechanism. Okay. Intense weather mechanism. Okay. Very intense. But when I talk about, say, for example, temperate cyclones, they are known for mild weather mechanism. Mild weather mechanism. Okay. Wind will be there, but not to the level of cyclones. Precipitation will be there, but not that heavy precipitation. Am I right? It is known for mild weather mechanism. And my dear friends, this tropical cyclones will be having an eye, right? It has eye has I. What is I if you ask me? The center of the cyclone. Right? Center of the cyclone is called as I, my friend. Correct. And talk about temperate cyclone. Temperate cyclone do not have an I. Temperate cyclone do not have an I. Okay, no I. Right? Very important, my friend. Okay. All the difference what I have brought in is very, 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 very important. Okay. I'm telling you, there is a chance that this difference itself can be asked as a question. Okay. Right. See 8 degree to 35 degree in both the hemisphere. But when I talk about mid latitude, nothing. Somewhere I understand, right? Somewhere around 60 degree mid latitude in both the hemisphere. Tropical cyclones will be having its formation only in water. Temperate cyclone can have its formation both in land and water. Genesis. Tropical cyclone is known for intense weather mechanism. Temperate cyclones are known for mild weather mechanism. Okay. And it has an I, right? Temperate cyclone do not have an I. My dear friends, in 2020 prelims question paper solved. Last year's question, my friend. I'm just taking on last year's question. searching it. Could have taken it from other websites, but not an issue. We'll just take it from UPSC website itself. My goodness, got it. Finally got it. Question number 99. Yeah. See, my dear friends. Okay. See, you do not know some of the facts here. Okay. But my dear friends, see, for example, question number 99, right? We do not know about, say, for example, the answer as such. But say, for example, at least few statements, you know, right or wrong. My friend. See, for example, what you have to do. Question number 99, last year preliminary examination question. Okay. You simply have to tell me whether the given statement is right or wrong. That's it. Question number 1, question number 99, statement 1. Jet stream occurs in northern hemisphere only. Right. This is statement 1. My dear friends, you tell me whether this is right or wrong, my friend. This is false. Why? Because somewhere, you know, the jet streams are there in both the hemispheres. So what you can do, what is the answer? What is the option given? Which of the following statement is correct? Okay. Wherever 1 comes in, you have to remove it. All right. Now you have the option of B and C. All right. B and C. And one more thing, B and C, correct. Say, for example, in this statement B and C, statement 2 is correct. Am I right? So statement 2 is not going to decide your answer. So even without reading the statement 2, you can put it as correct. But still, let me give you, the statement 2 says only some cyclone develops an eye. The statement is correct because tropical cyclone develops an eye, temperate cyclone, they don't have an eye. Am I right? That's the reason they say only some cyclones develop an eye. This statement is correct. What is the third statement? The temperature inside the eye of the cyclone is nearly 10 degrees less than the surrounding. Temperature inside the eye of the cyclone is nearly 10 degrees centigrade lesser than the surrounding. No, it should be higher than the surrounding. If it is colder, it will be a high pressure, right? Just because it is a warmer condition, it is a low pressure. So answer to this question is 2 only, my friend. But why I have just taken this right here? Jet stream also, you know, you can arrive at an answer. Right. This particular fact also, you know, you can arrive at an answer. Now, right? Okay. Of course, you do not know the complete answer to this. That we'll take it later. Okay. Right. Right. Okay. So what we have done, we have just taken the general difference between temperate and tropical cyclones. Okay. Right. So what we'll do now, we'll discuss about this tropical cyclone separately. Then we'll discuss about this temperate cyclone. Then we'll be discussing about this monsoon. Okay. So right, my friends, we'll just take a break. We'll take a 15 minutes break, my friend. Time is 10:33. Right. We'll be coming at us, right, back at 10:48. To be very precise, 10:49. We'll be back at 10:49. Okay. So in between this clouds, if you want me to keep it, I'll just keep it at cloud, because at least, right, you can keep observing things. Okay. So we'll be back at 10:48, 49. Michael, do you have any questions? Okay, right. So once the class is over, Pankaj, I'll answer your question. You have a doubt in jet stream, you said. Okay. Once the class is over, we'll just have this doubt being cleared. Right, my dear friends. So we are just talking about the difference between the tropical and temperate cyclones. The basic difference between them we have taken it. Correct? Right. Now, after discussing about the basic difference between tropical and temperate cyclone, what we'll do, right? Even if you want to skip this temperate cyclones, it doesn't matter. But tropical cyclones are very, very important for us. So, right. We'll just take the case of tropical cyclones. Now, already you know, right? The cyclones of lower latitude, you call them as what? Tropical cyclones. See, now comes the question. Okay, everything is fine. What exactly is a cyclone? See, cyclone has a character. Cyclone is known for high velocity wind, and cyclones are known for its heavy precipitation. See, generally, when I just talk about cyclones, see, for example, how exactly the government of India, okay, WMO's defined cyclones. Like Wikipedia, there is one Vikaspedia, okay. So if you want to say, for example, refer some of the very important information, basic information, authentic information, you may search in this Vikaspedia, okay, right. So what exactly is cyclone? Generally, according to WMO's classification, a wind which has a speed of more than a gale storm. Am I right? Particularly somewhere around, say for example, assume that more than 63 kilometers per hour. Right? You call them as what? Cyclones, my friend. Am I right? So this is according to WMO's classification. See, when I talk about this gale wind or gale storm, see, you call them as gale force. Okay, gale force according to World Meteorological Organization. Any wind which has a speed up to 63 kilometer per hour, you call them as what? Gale force. So what WMO defines? WMO defines that tropical cyclones to cover weather system in which wind exceeds gale force. It means what? Any wind which has a velocity of more than 63 kilometer per hour, you call them as what? Cyclones. Correct? This is the official definition. Now let's see. Indian classification slightly it may differ. This is WMO's classification. Now, right. So any wind system which has more than 63 kilometers per hour, right? You call them as what? Cyclones. See, there are different categories of cyclone. That's a different story. Okay. And one more thing, my friend, Indian classification is different. Okay. Okay, here itself, see. When we talk about Indian classification, Indian Meteorological Department, the classification is different. Okay. So what exactly is the difference according to them? Right, a wind speed, okay, a wind, right, which exceeds 61 kilometer per hour, you call them as what? Cyclone. So slight difference will be there. All right. So WMO's classification, Indian classification, both has a very slight difference. Okay. So don't mind about it. Okay, approximately, right? Even if you say more than 63 kilometer per hour, I am fine enough. This is WMO, World Meteorological Organization's classification. Okay. What is cyclones? We have an idea. I told you, cyclone is an intense low pressure system. The pressure system is intense. The velocity of the wind will also be very, very high. Okay, everything is fine. Right. Now comes the question: what is cyclone? Now comes the question: precondition. Right, origin, genesis of cyclone. What are the conditions that is needed for the cyclone formation? All right, cyclone formation. Right, my dear friends, condition, necessary condition needed for cyclone formation. If you ask me, okay, right, condition that facilitates the formation of cyclone, cyclogenesis. Right, conditions for cyclogenesis. Now, talk about the condition for cyclogenesis, my friend. Number one, it's an intense low pressure system. Now, as the case, right? we understand, right? It should have a high temperature, my friend. Number one, what you need is a high temperature. Okay. Now, whenever I say high temperature, my friend, somewhere I understand it is somewhere around 25 degrees centigrade. Okay. Marginally, it can be less or more, doesn't matter, right? Somewhere around 25 degrees centigrade. Now, you may wonder, why 25 degrees centigrade, 25, 26 degrees centigrade, you are calling it as a high temperature. You look at the AC, right? Say, for example, air conditioner. Most of the time, you will be seeing this 25 degrees centigrade and you are saying that it's high temperature. My friend, when I say 25-degree temperature or 25 degrees centigrade as high temperature, I'm not talking about the highest temperature. This is average temperature. Right, my dear friends, let me tell you, 22 degrees centigrade plus is always considered as a higher temperature. See, we are not feeling it because we are already there in one of the highest possible temperature, tropical region. Tropical region is the warmest region in the entire world, not even equatorial region. Alright, that's the reason, right? Even the so-called warm is not appearing warm to us. Okay, whatever be the case, this 25 degrees centigrade is the average temperature. Okay, right. Okay, right. So one precondition, I was just talking about high temperature. Number two, the second condition, what you need is more moisture, right? More moisture, or high amount of moisture. Okay, high amount of moisture. Okay, because moisture will further supply this latent heat, my friend. Okay, right. See, for example, generally, if you ask me, where exactly you will be having high temperature between land and water, if you ask me where exactly you will be having high temperature, normally we say land will have more high temperature than that of water. Okay. What about moisture? Where exactly you will be having more moisture? If you ask me, water will be having more moisture, my friend. That's the reason cyclones generally get formed in the place where there is a combination of both. What combination? A land which behaves more like that of water, or a water which behaves more like that of a land. All right. So both these, taken these two conditions, right? It means land and water combination. That's the reason cyclones are formed over marginal water bodies. What is this marginal water bodies, if you ask me? Sometimes you also call them as what? Continental water bodies. You call them as what? Marginal water bodies, or you call them as what? Continental water bodies. What is this continental water bodies? A water body which can behave like that of a land. A water body which is surrounded by land on three sides. You call them as what? Marginal water body. Even two sides, no problem. Influence of the land should be there. It can be a bay, it can be a gulf, or whatever it is. My dear friends, only in this marginal water body, right, you can have this cyclone having its genesis. Okay, very important. Right, that's the reason, if you remember, right? Right, I said where exactly they'll be having its origin? Tropical marginal water body. Now further, my friend, preconditions. Right, conditions for cyclogenesis, I told you, right? Preconditions for cyclogenesis: high temperature, high amount of moisture. Number three, cyclone as a circulation. What makes it as a circulation? Coriolis force. Coriolis force. My dear friends, that's the reason cyclone is absent in equatorial region. Right? Somewhere you can write it. Why? I'm writing it, my friend. Cyclone is absent in equatorial region. If you ask me what exactly is the reason for it, it is all because of what? Minimal Coriolis force. Right? Minimal Coriolis force or no Coriolis force at the equator. Okay. Coriolis force is very important because this is the one which is going to make this, say for example, cyclone as a circulation. Right? And my dear friends, given all these combinations, right? All these combinations, because cyclones is absent in equatorial, I am confining only to tropical region. Am I right? Higher lat means, so for example, the region where you have high temperature. Am I right? Moisture should be very high. That's the reason we have taken it at what? Tropical marginal water. Am I right? And my dear friends, one more condition is also there: pre-existence of a depression. Pre-existence of a depression. See, all of a sudden, right, you will not have one cyclone. See, for example, earlier also we said, right, how this cumulonimbus cloud is formed. Cumulus cloud should be there. This cumulus cloud will get, say, for example, intensified, and it will become cumulonimbus cloud. Similarly, some depression or a low pressure, pre-existing depression will be there. This depression will slowly get converted into deep depression, and this deep depression will get converted into cyclones. All of a sudden, tomorrow you will not have cyclones in Bay of Bengal. Slowly, steadily, it will get developed. Right. Right, my dear friends. Okay, right. So what is the precondition for the genesis of cyclones we have seen, right? So as I said, my friend, given all the preconditions that is needed for cyclone, cyclones are not universal, right? All this precondition, okay, even forget about the fourth precondition. Fourth precondition is temporal in nature, okay. Temporal in nature, every time it is not going to have its presence. Right? But what about the others? Right? Say, for example, high temperature. When I talk about this high temperature, high amount of moisture, Coriolis force given together, we said tropical marginal water body. This tropical marginal water body is not universal. Only limited geographical locations you have this. Right? So we just search for this, my friend. My dear friends, okay, I'll just maybe first I'll just show you in world map. Where all will be having the cyclones in the world map, I'll show you. Then I'll just bring this area also. Okay. Specific names I'll just bring it. Okay. So if you ask me what are the regions in the world which experience this cyclone, okay, it is not universal. It is not at all universal. Only the limited geographical locations in the world experience this cycle. In that regard, my friends, some of the regions which experience cyclones. Okay. Number one, this Gulf of California and Gulf of Mexico, along with this Caribbean Sea region. Am I right? No. Marginal water body. Okay. Marginal water body. As I told you, right? Say, for example, water body should be there, but this water body should be covered with land. Am I right? It should be covered by land. Okay. Right. So, my dear friends, number one, it is Gulf of California. Gulf of California. Gulf of California. Let me not write these numbers. Simply, I just give the names, right? Number one, it is Gulf of California. And number two, my friend, it is Gulf of Mexico. Gulf of Mexico, along with this Caribbean Sea. Gulf of Mexico is the place where you have intensified cyclones. But only thing is that in this region, you don't call them as cyclones, you call them as what? Hurricanes. Right? You call them as what? Hurricanes. As I said, you don't call them as cyclones, you call them as what? Hurricanes. This region. Okay. Right. So, for example, yes, North America, you call them as what? Hurricanes. You don't call them as cyclones. Similarly, if you're there in Bay of Bengal region, right? If you're there in Bay of Bengal region, right, Indian Ocean region, yes, it is known for cyclones. Similarly, if you're there in Arabian Seaside, yes, again, Arabian Seaside is known for cyclogenesis. Similarly, if you're there in, say, for example, Mozambique Channel, right, These are the regions which is known for cyclones, right? Arabian Sea, Bay of Bengal, and Mozambique Channel. All right. And if you ask me, okay, what exactly they are called as? Yes, they are called as cyclones itself. All right. Indian Ocean region, this phenomena, you call them as what? Cyclones. You call them as cyclones. Okay. North America, you call this as hurricanes. Indian Ocean region, you call them as what? Cyclones. Right? So where are the cyclones will happen in Indian Ocean region? Bay of Bengal, Arabian Sea, so Bay of Bengal, Arabian Sea, and Mozambique Channel. Mozambique Channel. So these are the places where in Indian Ocean region you experience cyclones. See, what is the criteria? This should be there in tropical latitudes, 8 degree to 35 degree in both the hemispheres, northern and southern hemisphere. Right? And similarly, my friend, say for example, you call them as cyclones. And if you're there in, say for example, the eastern side, right? The eastern side of Asia. Okay. You're there in the eastern side of Asia, right? Particularly if you're there in South China Sea, right? All this region, including Sea of Japan, right? Right. Gulf of Thailand, all these regions, right? All right. You call it as, say for example, here also, right? Particularly when I talk about the central region, right? You're there in South China Sea, right? South China Sea, right? South China Sea. See, even outside the South China Sea, you have this, right? I'm not denying it. Okay. But in this region, very popularly, you call them as what? Typhoon. Right? You call them as what? Typhoon. Right? Okay, you call them as what? Typhoon. Okay. So just want to tell you at all different places, right? Different regions, cyclone takes different names, right? North America, it is called as hurricanes. Indian Ocean region, it is called as cyclones. South China Sea, it is called as typhoon. All right. Similarly, if you're there in Australia, right? If you're there in Australia, right? Particularly this Gulf of Carpentarian region. Okay. Gulf of Carpentaria. Am I right? So here you call them as what? Willy Willy, Northern Australia, right? Northern Australia or Gulf of Carpentaria. So this Gulf of Carpentaria region, you call them as what? Willy Willies. You call them as what? Willy Willies. Okay. So what I want to tell you, mechanism is one, right? Mechanism is one, but they take different names in different regions, right? So again, I repeat, the names can be asked as the match the following type of a question, right? So North America, both Gulf of California and Gulf of Mexico, we call them as what? Hurricanes. Indian Ocean region, Arabian Sea, Bay of Bengal, and Mozambique Channel, we call them as what? Cyclones. South China Sea, particularly, you call them as what? Typhoon. Right? You see even Sea of Japan, right? Gulf of Bohai, Gulf of Thailand, South China Sea, right? Even East China Sea, all these regions you call them as what? Typhoon, right? The East Asia, you call them as what? Typhoon, my friend. Right? And when I talk about Australia, the northern parts of Australia, you call them as what? Willy Willies. Right? So these are the different regions in the world which experience what? Cyclones. Correct? Okay. Tropical cyclones, to be very, very precise. Okay. Very important, my friend. 7 different regions. Okay. 1, 2, 3, 4, 5, 6, 7. 7 different regions. Right. They experience cyclone. Again, I'm telling you, cyclone is absent in this equatorial belt. Cyclone is absent in this equatorial. Why cyclone is absent in equatorial belt? Right. Again, let me confirm it, reiterate it, because Coriolis force is absent. Okay, right. Now, my dear friends, conditions for cyclogenesis we know. Different regions in the world which experience cyclone, that also we know. Am I right? Now comes the question. Okay, everything is fine. Now, how this structure of cyclone will look like, my friend? What is the character of cyclone? Anybody can answer. Am I right? Cyclone is known for high intensity, right? Say, for example, high velocity wind, because the definition of the cyclone itself is defined based on the wind velocity. WMO's classification more than 63 km per hour. Indian classification more than 61 km per hour, something like that. Right now, and they say it should be a sustained wind velocity. Sustained wind velocity means at least this wind velocity should continue means at least for 3 minutes and above. It's not like that one, say for example 10 seconds it's going very fast, then again coming down. No, not like that. 3 minutes. Sustained velocity means at least 3 minutes the velocity of the wind should be maintained. Okay, everything is fine. Now comes the question, how this cyclones looks like, my friend, structure of cyclone. Right. See, for example, cyclone has some unique character. Tropical cyclone, all those things what exactly I'm just discussing is the tropical cyclone. When I say structure of cyclone means I'm just talking about the structure of tropical cyclone. Okay. So how exactly they look like, I'll tell you. Maybe from the representative or representational image from the structure of cyclone. This is the closest diagram. What exactly you have in your, say for example, NCRT books. Okay. The only thing is that NCRT comes with the, okay, this is the exact image what you have in NCRT. Okay. Don't mind, by the time you understand this, okay, right, the entire course will be over, so never mind. Okay. Very carefully, if you are looking at this image, my friend, right, what I want you to see here in this image, some of the basic essence. The center of this cyclone, you will be having an eye. Okay, eye. All right. All side of this eye, right? This eye will be bounded by a structure called as eye wall. Okay. It will be bounded by this structure called as eye wall, my friend. Am I right? Along the edges of this eye wall, what you will be having is a rising convection. Am I right? Actually, it will not rise directly. My dear friends, it will start spiraling. It will be having its spiraling effect. Okay. See, for example, anywhere you take it, any other diagram you take it, so you'll be seeing along the eye wall, it will start spiraling. Okay, it will start spiraling. We'll be having this spiraling effect. Okay, whatever be the case. Okay, whatever be the case, right, it will be having its spiraling effect. Okay, but whatever, right? I'm just right going for right this image what it is given in NCRT. Am I right? Forget about the spiraling effect. Right, I'm just simply going for this image which is given in NCRT. Right, for your reference. Okay, just for your reference. Now the same thing I'll just draw it here. Same thing I'm just going to draw it here, but in a different fashion. Now, you already know the center of the cyclone. The center of the cyclone, you call them as what? Eye of the cyclone. The eye is the one which regulates the entire mechanism. Right? You call them as what? Eye of the cyclone. Okay. You call them as what? Eye of the cyclone. Okay. This eye of the cyclone is bounded in all direction by a wall-like structure. Again, very popularly you call this as eye wall. Okay. You call them as what? Eye wall. You call them as eye wall. Right. Now you know the fact along the eye wall. Okay, you call it as eye wall. You call them as eye wall. So both side of this eye, all side of this eye. Why both side? Because it is three-dimensional in nature. Okay. All side of this eye, what you have is eye wall. So you know the fact that along the eye wall, right, along the walls of this eye, right, what you have is a very strong convection. Actually, it goes in a spiraling fashion. Right, it goes in a spiraling fashion. But say, for example, air mass rises. Very strong convection. Okay. But if you're there at the center of this cyclone, my friend, very center of this cyclone, what you will be having is a subsiding convection. The center of the eye will be having a subsiding convection. Whatever be the case, both the places what you have is what? Vertical movement. Now, eye is a low pressure. Any low pressure will have one opposite type of a pressure at the tropopause level. Okay. That you call them as what? Anticyclone. To be very precise, this structure at the tropopause level, you call them as what? Blocking anticyclone. Right? We call them as what? Blocking anticyclone. What is this blocking? You forget about it. Just call it as anticyclone. Because I understand any low pressure system we call them as what? Blocking anticyclone. Any pressure system at the surface will always have one opposite type of a pressure system at the tropopause level. Okay. Now, my dear friends, you already know that, say for example, any cyclones is known for heavy precipitation and high velocity wind. Am I right? So this heavy precipitation and high velocity wind, if you ask me, from where exactly they start only from this eye wall, my friend. Right? They start only from this eye wall. So what I want to tell you, right? Say for example, very near to this eye wall, okay, or within the eye, right? What I understand, this region is completely devoid of any wind, right, and any precipitation. The precipitational, say for example, the precipitation zone starts only with eye wall, my friend. So when I talk about the precipitation zone, right, it starts only from eye wall and it decreases towards the outer margin, right? So this is what we call them as what? Rain zone, my friend. We call them as what? Rain zone. Right, it's a rain zone. So what is very interesting, when I talk about the eye, the mechanism what exactly regulates the entire system of cyclone. When I talk about the nature of this eye is known for windless and rainless condition, my friend. It is called as rainless and windless. See the beauty. What exactly is regulating the entire cyclone is this eye. Eye is something like, okay, though you call them as eye, let me call this is more like heart of the cyclone. This is the one which is generating the mechanism, intensifying the mechanism, right? But this eye is known for windless condition and rainless condition. My friend, this eye is known for its right absolute calm condition. It is known for its calm condition. Absolute calm condition. No rain, no precipitation. Am I right? It's known for calm condition. Something like, say for example, horse latitude. Am I right? Horse latitude. See, for example, no rain, no precipitation, completely calm. Correct. That's the reason I normally used to say, if you want to escape a cyclone, the best way of escaping a cyclone, try to hide yourself within the eye of the cyclone. Okay. That's a sarcastic way of saying. Am I right? Okay. So eye of the cyclone is known for windless and rainless condition. Right? Why windless condition? Because eye of the cyclone is generally devoid of this cloud cover. Am I right? Maybe because more of centrifugal effectivity. Am I right? Whatever you call them as, right? Number two, my friend, they are known for windless condition. Why? Because here the convection is more than the horizontal movement. Right? Horizontal movement is advection. There is no advection. What you have is only convection. Correct? Right. Right, my friends. So when I talk about cyclone, how exactly they look like? Very near to the eye wall, what you will be having is a cumulonimbus clouds. Right. So as you move to the outer margin, what you will be having is a cumulus cloud. Slowly, steadily, right? The intensity of the cloud will go on decreasing. Okay. So how these cyclones look like, we have an idea. Right. So my dear friends, all important facts we have seen. And normally this rain zone to rain zone is what? You call them as what? Size of cyclone. You call them as what? Size of cyclone. And universally, my friend, I talk about size of the cyclone normally, right? That also I'll just give you somewhere, right? Say I'm just selecting some random image, okay? Some random image. All these are satellite images, right? These are satellite images. Assume that, okay, I'm just selecting this image. No. Just for your reference, maybe a few things you may understand. Okay. Some random image. See, for example, when I just talk about the size of the cyclone, right? The size of the cyclone. This is what? Normally we call them as what? Size of the cyclone. Okay, size. Size is nothing but what? The diameter, you call them as what? Size. Okay. And when I talk about, say, for example, the very center, this is what we call them as what? Eye of the cyclone. Correct? What exactly you're seeing here is what you call them as what? Eye of the cyclone. Okay. You call it as eye of the cyclone. Right, my friend. So eye normally it is devoid of what? Say, for example, bad in it. Okay, let me write it as size of the cyclone. What exactly you're seeing here is eye. Okay. Right. What you're seeing here is the eye of the cyclone. Actually, you're not seeing an eye. What you're seeing is a blocking anticyclone. No problem. Consider it as eye. Now, generally, my friend, if you ask me, okay, normally, what exactly will be the size of the cyclone? Global average, the size of the cyclone is somewhere around 650 kilometers, but it can go up to 1000 kilometers. Right? It can go up to 1000 kilometers. Nothing wrong with it. Up to 1000 kilometers. Okay. Now, if you ask me what exactly will be the size of an eye, my friend, eye can vary anywhere between 30 to 80 kilometers. Okay, eye of the cyclone. All right. Right. Everything is fine. Right. So, what is eye? What will be the size of an eye? What can be the size of the cyclone? Everything we have an idea. More is the size, more will be the intensity of this cyclone. Right? Right, my friends. So everything we have an idea. Now, few informations we take it. Preliminary examination based question. Normally, they may ask you, right, what exactly is the direction of circulation? Right? What exactly is the direction of circulation? Right? In that regard, a few things you have to remember, my friend. If you ask me direction of circulation, I'm talking about cyclones, my friend. I'm just talking about cyclones, right? Direction of circulation, right? Of course, I'm just talking about tropical cyclones, right? If you are there in northern hemisphere, right? Northern hemisphere, the direction of circulation is counterclockwise in direction. Right? Counterclockwise in direction. Right? If you are there in southern hemisphere, things will differ. Am I right? It is clockwise in circulation. Clockwise. You call them as anti-clockwise, or you call them as what? Counterclockwise around the way, right? I am talking about direction of circulation of course, we are discussing about tropical cyclones, and of course, this is about tropical cyclones. Tropical cyclones. Okay. Not only tropical cyclones, even when I talk about, say, for example, right, this temperate cyclones also, say, for example, they have their own, right, counterclockwise in direction when it comes to northern hemisphere. Now here, only one you remember. What is that I have to remember? You remember direction of cyclone, right? Circulation of cyclone in northern hemisphere alone. Right? Cyclones are counterclockwise in direction in northern hemisphere. That's what you have to remember. If you're going for southern hemisphere, you change it to clockwise. If I'm just going for anticyclone in northern hemisphere will be clockwise. Okay. So my dear friend, what you have to remember, direction of circulation of cyclone in northern hemisphere alone, you remember. Its combination will give you the direction of the other mechanisms. Southern hemisphere, right? Even say, for example, if I just talk about anticyclones, what exactly is the direction, everything will be having an idea. See, here, why exactly such cyclones or such direction comes in, that is not important for us. Okay. Why? Say, for example, of course, Coriolis force plays a very important role. I'm not denying it, but do not insist more on it. That's what I'm saying. Okay, right. Right, my dear friends. All the important facts about cyclones we have taken it. Direction of circulation also we have taken it. And my dear friends, again, I'm repeating it. The nature of the eye is very, very important. Though I have written in a very, say, for example, objective fashion. If you want to describe it further, you can describe it. I said, eye of the cyclone is known for windless and rainless condition. Something very important. Important. Why there is no wind, if you ask me? Because what dominates within the eye of the cyclone is convection, not the advection. Advection means horizontal movement. Convection means vertical movement. Why there is no precipitation? Because this is cloudless in condition. That's the reason we said it is known for its absolute calm condition. My dear friends, see, normally we have the mechanism called as landfall. I'll just come to it later. Okay, you have the mechanism called as landfall. Okay, as I said, I will just come to it later. Okay. What is the precondition? What is the cyclone we have seen? What is the precondition that is needed for the cyclogenesis we have seen? What are the different regions in the world which experience cyclone? That also we have seen. And we have seen the structure of cyclone. And my dear friends, finally, right, we'll talk about this dissipation of this cyclone. How exactly the cyclone is coming to an end. Okay, we'll just talk about the dissipation of cyclone. Okay. So how, as I said, how exactly cyclone is coming to an end. See, for example, whichever phenomena is, if it is having an origin, it should come to an end. Right? So when I talk about dissipation of the cyclone, it's all about the end of cyclone. Okay. How exactly cyclone is coming to an end, right? Dissipation of the cyclone. Now, my dear friends, whatever is the character of cyclone, if the same is being reduced, all right, if the same is being reduced, okay, if the same is being reduced, okay, you call them as what? Dissipation. Okay. Now, for example, I put this way: cyclone is known for heavy precipitation. If the heavy precipitation is getting hindered, somewhere I understand dissipation of the cyclone is starting. Cyclone is known for heavy, high velocity wind. Am I right? If the wind speed is restricted, the definition, the character of the cyclone itself will come to an end. Am I right? This is another way. Say, for example, Dissipation means almost losing its energy, losing its character. Cyclone coming to an end. Cyclone is short-lived, my friend. Normally, if you ask me cyclone can live up to 4 to 5 days, my friend. Extraordinary conditions, 7 to 8 days. All right, that's it. Okay, right. Now, dissipation of the cyclone starts with landfall. It starts with landfall, my friend. Okay, that also I'll write it, right? It starts with landfall. Now comes the question, okay, landfall is a technical term, am I right? Now comes the question, what exactly is a landfall? That's what I said, right? Right. I'll just discuss it later. This is the time to discuss. What is this landfall? See, for example, most of the time when you are reading about cyclone, you'll be coming across this word called as landfall. What is this landfall? Cyclone entering the land. Is it the entire cyclone entering the land? You call them as a landfall? No, my dear friend. You have a coastline, one side you have a land and one side you have a sea. Am I right? So in that, when I talk about landfall means the eye of the cyclone entering the land area, not the cyclone as such, right? Eye of the cyclone entering the land area. This is what you call them as what? Landfall. Okay, right. So somewhere you can write it, right? It is the eye of the cyclone entering the landfall, right? Eye of the cyclone entering the landfall. Sorry, eye of the cyclone entering the land. Right? You call them as what? Landfall. Okay. Normally they say, right, it means landfall has taken so many minutes, so many hours. Not the outer margin. Am I right? So kindly take it, what is a landfall, right? So landfall is nothing but what? Eye of the cyclone entering the land. Eye of the cyclone entering the land. Entering the land, you call them as what? Landfall. My dear friends, dissipation starts with the landfall. Why? See, for example, number one. When I just talk about, say, for example, land versus water, I understand in water friction is minimum, land friction is more. Already we have seen, if you remember. All right. So more is the friction. With the landfall, what happens, right? The velocity will come down, my friend. Number one, right? It will increase the friction. All right. It will start with friction. Means when I say it starts with the landfall, it will increase frictional drag, more frictional drag, right? More frictional drag. If the frictional drag is more, I understand that the velocity will start reducing. All right. So it will result in reduced velocity, one of the very important character of the cyclone. It will start losing its character. Am I right? More frictional drag. Number two, right? Cyclone needs more of a moisture. As and when it enters the land area, there will be a lack of moisture. Lack of moisture. Okay. Right. So it means water you will be having more moisture, but land you will be not having much of moisture. So these are the two very important factors why exactly cyclone starts dissipating. There is also one more factor, blocking anticyclone, but I don't want to bring it. Am I right? Only these two factors you take it. More frictional drag. Am I right? The velocity of wind will start reducing. And the lack of moisture, see, moisture is needed to intensify this weather mechanism. Am I right? So that will come down. Okay, right. Now see here. Okay. Instead of you searching the map, I'll just show you my. Cyclone as a topic is important for your prelims as well as mains examination. Okay, right. This is slightly distorted map of India, but never mind. I'll just choose some other map. I want you to answer a few things, mate. What is that I want you to answer? I'll tell you. See, for example, when I talk about India, no, somewhat, yeah. And talk about India, Arabian Sea and Bay of Bengal both are known for genesis of cyclone. Right, both the numbings has the cyclogenesis, right? But only thing is that Bay of Bengal will have more cyclones than that of Arabian Sea. The statistics says for every one cyclone in Arabian Sea, there will be 3 cyclones in Bay of Bengal. If you ask me why, the reason is very simple. The surface temperature of Bay of Bengal is more, because Bay of Bengal is more continental than that of Arabian Sea. Correct. So cyclones, number of cyclones will be more in Bay of Bengal. This is fact number 1. Okay. The ratio between Arabian Sea and Bay of Bengal, as I said, the ratio is 1:3. See, if your book says 1:2, I don't mind. Am I right? So actually speaking, it is close to 1:3, my friend. When the recordings, when the history of recording started, am I right? Almost approximately we have recorded 150 cyclones in Arabian Sea and somewhere around 450 cyclones in Bay of Bengal. Okay, right. Now, right, my dear friends. So, for example, right, Arabian Sea versus Bay of Bengal, we have an idea. Okay, I told you why. What is the reason? Surface temperature of Bay of Bengal is more than that of Arabian Sea. Why? Because Bay of Bengal is more enclosed. Bay of Bengal is more enclosed by land. More enclosed by land, my friend. Okay, this is one. Number 2, assume that, say, for example, cyclones of Arabian Sea is also entering the land. The Bay of Bengal is also entering the land. If you ask me, which cyclones can very easily enter the land? If you ask me, I would say that Bay of Bengal cyclones can very easily enter the east coast of India. One more reason is also there. Normally, if you ask me, normally, my friend, okay, see, when I talk about the period of cyclone, particularly in India, right, cyclones will have, say, for example, mostly you'll be having in the month of May, or you will be having in the month of November and December. Okay, these are the cyclone months in India. Okay, May, you will not have that many number of cyclones. See, you can be there in the later part of April or early part of June. That's a different story. But pivotal region, pivotal period is May. May, November and December, this is the period of cyclone in India. Okay, if you want to make a note, somewhere you make a note. Okay. Now, forget about this May. Normally, when I talk about December, November and December cyclones, generally these December cyclones and November cyclones, they will move towards poles and slightly towards west. Okay, that's the reason Bay of Bengal cyclone entering the west coast of India is more prominent or normal, common than the Arabian Sea, right? Say, for example, cyclones entering the west coast of India. Okay, so the probability of Arabian Sea cyclones entering the west coast itself is very less because of the path of the cyclone. All these are facts. But now what you do? Let's go for commonality. Assuming that Arabian Sea and Bay of Bengal are having equal number of cyclones, and assuming that both are entering their respective coast, even then, right? Assuming all this fact, even then, my friend, I'll tell you, Arabian Sea cyclones will not easily enter the west coast, but Bay of Bengal cyclone will easily enter the east coast. Can you tell me what is the reason for it? For a very long time expecting an answer from you. Can you tell me, my friends, what exactly is the reason for it? Very good. It is Western Ghats, my friend. See, I'm not saying cyclones can never ever have its landfall, but cyclone having a landfall in west coast of India is a very rare phenomenon. Once in a century it happens. Nisarga, it has happened. 2020, early 2020, it has happened. Right? That's an exception. Okay. But whatever be the case, my friend, eastern coast, very easily cyclones can enter because what you have is extensive plains. Right? What you have is extensive plains. What you have is, say, for example, West Bengal, Lower Gangetic Plain, Odisha, Utkal Plains, Andhra Pradesh, Northern Circles, Tamil Nadu, Coromandel Plains, very extensive plains. But when I talk about West Coast, very narrow. If at all, if cyclone have to enter the West Coast, the most ideal location for it to enter the West Coast is Gujarat. So that's the reason. In West Coast, Gujarat is more prone to cyclone than any other states. Even Kerala to some extent, but not Maharashtra, not Goa, not Karnataka. Why? Western Ghats. Gujarat is more prone. Why? Plains. Okay, right. Right, my dear friends. So somewhere, but even say, for example, when I talk about Bangladesh, my friend, entire Bangladesh is prone to cyclone. Why? Because entire Bangladesh is a plain. Right? Entire Bangladesh is a plain. And moisture also is not restricted. You have, say, for example, rivers like Padma and Jamuna. Ganga is called as Padma and Brahmaputra is called as Jamuna in Bangladesh. Supply of moisture is also more. In complete Bangladesh is a plain. That's the reason cyclone entering Bangladesh normally devastate entire Bangladesh. Entire Bangladesh is prone to cyclones. Okay, right. Right, my friends. Because I understand, yeah, wherever you have plains, this frictional drag will be minimum. The velocity will not come down. Okay. So, my dear friends, the dissipation of the cyclone also, right, we have discussed about. As a point, I'll start added. Blocking anticyclone also, blocking anticyclone also reduces the efficiency of the cyclone, but not at the initial stage, at the later stage. Okay, right. So with this, cyclone from the genesis, right, from the origin to the completion, we have done it, my friend. Okay. What is tropical cyclone? Condition needed for genesis, regions of cyclones, structure of cyclone, dissipation. Even the direction of the cyclone, we have taken it. Am I right? Everything. What is landfall? That much we have taken it. Right, my dear friends? Now everything is over. Finally, we'll just discuss about this fact. Naming of cyclone. Right? See, for example, every cyclone has a naming, right? Name. Am I right? Naming of cyclones. Every cyclone, for example, nowadays, I should call this naming of tropical cyclones. Okay. Already this question was asked in UPSC mains examination, so they're not going to ask you again. But still, every time, say for example, you take a cyclone's name, am I right? Now comes the question, why these cyclones are named? What is the reason for naming a cyclone? Right, number one. Number two, how? Why it is cyclones, why it is named, and how it is named. This is what we are going to discuss. Okay. Number one, if you ask me, okay, why cyclones are named, I would say, okay, I'm not going to write anything. Simply, I'm just going to discuss about it. Okay, why cyclones are named, if you ask me, it is all because of disaster mitigation. Now, you may wonder, right? How does disaster mitigation and naming the cyclone, what connection it has? Very simple. What is disaster mitigation? What is a disaster event? Any sudden and unforeseen event, right, which can result in loss of life or property or sometimes both. You call them as what? Disaster. Any unforeseen incident of higher magnitude, you call them as what? Disaster. Okay, yes. There are plenty of disaster, man-made, natural, whatever it is. Coming to the cyclone, cyclone is also a disaster. It can result in loss of life or property or sometimes both. Now, my dear friends, just by naming a cyclone, how you can reduce the effect of disaster. Mitigation means conscious effort what you take to reduce the eventual impact of any disaster. You call them as what? Mitigation. Try to prevent a disaster, if not mitigate it. Okay, right. Try to reduce its impact. That's what you call them as what? Disaster mitigation. Now again, I'm asking you, how this naming of a cyclone helps in disaster mitigation? Very simple. My dear friends, one of the very important component in disaster management is communication. Okay, effective communication. Say for example, if a cyclone is, say for example, approaching a particular place, you have to communicate the same to the local community so that, right, the lives can be put at the safer zone, elevated structures. Am I right? Where water will not be inundated, where the structures will not collapse. Somewhere they'll be in a safer zone. So you have to communicate to them, right, effectively. And say, for example, if at all if this cyclone has a name, right, this communication becomes very easy method. Right? How I'll tell you. earlier, before this, say for example, practice of naming a cyclone came in, right? Only after cyclone devastating a particular place, you will be naming this cyclone. Okay, cyclone Dhanushkodi, right, which was devastated in 1970s. Am I right? Right, cyclone of Sagar Island, something like that. Am I right? Only after it becoming infamous, becoming famous for a wrong reason, you call them as what? Infamous. Okay, only after cyclone devastating a place, you name this cyclone. Right. But oh, once you name it, after identifying it, okay, I have identified, okay, one cyclone had its formation in Bay of Bengal, right? You follow it. I mean, if I have a name, say for example, I'm just calling it as what? Buruvi, right? Right. This cyclone I call them as Buruvi. Right. Now I am saying that okay, Buruvi is there in Bay of Bengal. Okay, people becomes alert. Somewhere I said Nisarga is formed, right? Say for example, in Arabian Sea. Right, say for example, it is north of Lakshadweep Island and it is moving towards north and western direction. I mean, people will be alert. My dear friends, once you name a cyclone, the communication becomes effective. Very easily you can communicate, right? And the target audience will also understand that what you're talking about. Am I right? So communication becomes very easy. And even if you have more than one cyclone being formed in the same region, differentiating them also becomes very easy. Now you can say Nisarga and Buruvi, they formed almost very near to each other, something like that. You can say Nisarga is moving in one direction and Buruvi is moving in some other direction. So somewhere you can say that. So one line, the purpose of naming a cyclone is for mitigating the effect of disaster management. How? By facilitating effective communication. Okay, now I understood. Now you tell me how exactly this practice started. See, this practice almost started in World War II period, my friend. They started naming the cyclone. Once they identify the cyclone, they started naming this cyclone. Earlier, they started using this phonetic alphabets. Am I right? The first cyclone will be called as alpha, beta, gamma, so on. Right? They'll be right, delta, right? Accordingly, they'll be calling this. Okay. Now, what happened somewhere? See, for example, they went for this right. I mean, phonetic alphabets. But one thing, they understood that okay, these are not common names. People are feeling very difficult to understand what it is. Am I right? So then, what they thought, they went for a common name. Am I right? So initially they started with naming the cyclones in annoying politicians' name, my friend. Like if you don't like a politician, you name the cyclones in that particular, say for example, name. But that has become a derogatory practice. Immediately that was stopped. Then they went for systematic practice in 1950s, my friend. In 1950s, right? Say for example, they started generally this North American region. They started okay with this practice. They started naming the cyclones in person's name. But what they did, 1950s, right? Cyclones were almost named in alphabetical order. But all the cyclones will be named in female name. Right. Say, for example, the first cyclone of the year will be called as Andrea. Second cyclone will be called as Beulah. Third cyclone will be called as Catherine. So on it will be called. Am I right? So that's how, say, for example, if I just talk about, say, for example, they're very optimistic that you'll not have like more than 26 cyclones, but they have proposed only 21 cyclones, North American region. Okay. Whatever it is, they started naming the cyclones in females' name in alphabetical order. 1970, they started on agitation. I mean, they said, how can you name the cyclones in females' name? Right. Then where the say, for example, it is very derogatory in practice, right? You cannot do that. Then they thought, okay, meteorological department thought, okay, your issue is resolved. Now onwards, no female name only. They have included also men name, my friend. So 1970s onwards, what exactly is the practice? Even today, we are following the same thing, right? Same alphabetical order, person's name, right? But in alternate sequence on of male and female. Am I right? So, for example, if you understand this logic or this one particular line of this concept, match the following type of the question if they're asking for a chronological sequence, right, of cyclones, very well you can answer it. Okay. So, my dear friends, as of today, North American practice or North Atlantic practice, what you have, right? Right. Say, for example, Anna, Bill, right? Claudetta, Danny, etc. So the first name is female's name, second name is male name, third name is female name, fourth name is male name. That's how it goes. Am I right? Right. This is what the practice is, my friend. Okay. Right. Alphabetical order. But in, right, as I said. Okay. Alphabetical order, right? Female, male, female, male, etc. Next year, what happens? This year, right? First name was female name. Second year, the first name becomes men name. Okay. Right. Whatever it is the case, what you have to remember is very simple, my friend. It is named in alphabetical order. That's it. Okay. Named in alphabetical order. Now, what is the beauty? Already we have a set of preconceived names for tropical cyclones. Sarcastically, if you want me to say, I would say names are already there. We are just waiting for the cyclone to come. Once the cyclone comes, you take the names from the list and you assign it. That's it. Names are there. Okay, right, my friend. Right. So they have a, say for example, 6 set of list already there. Am I right? Not the map. A detail, knowing the detailed way is not needed. Once it becomes infamous, they will not reuse it. They will not reuse it. All these things are not needed. Okay. Now, my dear friends, like North American practice, what is needed is Indian practice. To be very precise, right? What we need is what? North Indian Ocean Basin. Okay. North Indian Ocean Basin. Say, for example, the practice is slightly different. What is it? I'll tell you. 13 countries are there. In North Indian Ocean region, 13 countries are there. Right? What are the 13 countries, my friend? Bangladesh, India, Iran, Maldives, Myanmar, Oman, Pakistan, Qatar, Saudi Arabia, Sri Lanka, Thailand, UAE, and Yemen. See here, it is given in alphabetical order. But if you're there in your atlas, somewhere you take it, right? There is Oman, Yemen, right? Then say for example, you are there in Saudi Arabia, okay. Then you are there in Qatar, even in Iran you add it, right? UAE you can add it, all these Middle East countries you can add it, right? Then Pakistan, right? India, Lakshadweep, Sri Lanka, right? Bangladesh, Myanmar, Thailand. Right? So ALF means geographically also you can add it. 13 countries are there. Right? 13 countries are there, right? Have contributed 13 names each. As of today, we have 169 preconceived names. Okay. Now you guys watch for it. Right? Month of November and December, you will be having cyclones, right? In this region, my friend, the last cyclone what we had is IAS. The next cyclone, what we are experiencing or we are waiting for it is this cyclone called as Gulab. Okay, Gulab. Gulab and Shagin are the 2 cyclones what you will be encountering at any time in the future in North Indian Ocean Basin. Not necessarily that it should happen only in India. It can happen in any of these 13 countries. Am I right? Any of these 13 countries, my friend. Okay, so what I want to tell you, what is the purpose of naming a cyclone? I have told you, right? How it is named, that also I have told you. Whatever be the case, it is preconceived names. Already list is there. Once you say, for example, say that this is the cyclone, right? You have identified a cyclone, a deep depression has become a cyclone. Then you take the name from it, assign it. That's it. Okay. So, right, my friends, this is all about cyclone. Cyclone is a very important topic both for your prelims as well as mains examination. Somewhere, cyclones, I'm just stopping it here, my friend. This temperate cyclones and monsoon, right? I'll just handle it in tomorrow's class, my friend. So, somewhere, I will stop the class here at this moment, right? So, any doubts you can ask me, my friends. Pankaj was asking some doubt, right? Yeah. Yes, Pankaj. Now I can hear you, Pankaj. Even if you want to say, for example, ask the question orally, you can ask.
Yes, sir. We have seen that jet streams goes from west to east, but for the onset of monsoon, there should be easterly jet stream. So
yeah, what you are saying is perfect. When I talk about onset of monsoon, there is one jet stream called as tropical easterly jet, right? It's called as tropical easterly jet. But this tropical easterly jet is a temporary jet. What we were discussing earlier is a permanent jet stream. Okay, what will be there throughout the year? But these are temporary jet streams. Temporary jet streams or not westerly in fashion. They can have north-south direction, south to north direction, right? I put it this way, they can flow in any direction. That's the idea. Okay. Only the permanent jet streams flows from west to east. Is that okay?
Yes, sir.
Yeah.
And sir, you will take oceanography or?
Now, I think oceanography is taken by Ashik.
Okay,
That's what I heard.
Sir, I have a question on this thermocline THC. There was this thermohaline.
Thermohaline. Okay,
compound.
thermohaline. Yeah. See, thermo means temperature. Haline means salinity. Okay. In oceanography, two places you will be coming across thermohaline. One, ocean currents also you will come across thermohaline. Right. One, that intermixing zone also you call them as what? Thermohaline. Which one you're talking about?
Sir, the circulation, this AMOC, Atlantic Meridional Overturning Circulation. I read in news that this AMOC will slow down and northern European climate would be very, very cold. So I wanted to know how it happened.
Okay. That I'll tell you in the next class. Even see, for example, I'm not following the news. I'll tell you in the next class. Not an issue. I'll just refer it and tell you.
Okay, sir. Okay, sir. Thank you, sir.
Yeah, boss. Okay. Anything else? Anything else? Anybody else is having a question? Okay, right, my dear friends. So somewhere I'll just wind up the class here. Right. So tomorrow we can complete it. What is remaining is only monsoon and temperate cyclonic circulation. So tomorrow we can complete it, and the world regional classification of the climate also we can do it at the end. So thank you, and right. God bless you, my dear friends.